Okay, so we're on projectiles and we're going to look at a classic question where we have to derive the equation of the position of the projectile. Okay, so as ever I'm going to approach it the same as all my projectile questions. I've got some words here, so I'm going to turn those into a picture. So a small ball P is projected with a speed of 5 meters per second at an angle of theta. So there we go. Theta, this is 5 meters per second. Above the horizontal from a point O. Okay. It moves freely under gravity, which means we've got a projectile. Okay. The only thing affecting it is weight. The horizontal and vertical displacements from O at any time t are called x and y. So I'm going to just continue my picture. Okay, there's my horizontal ground. So if I say we're here at the minute, okay, there's P, that's at point x, y. Okay, so here's my x distance and here's my y distance. So I've drawn myself a picture. When I've drawn a picture, I'm going to write out Suvat. Okay, so first of all, looking horizontally, we have moved a distance of x meters. Okay, we are going at a speed of, now we're adjacent to the angle when we go horizontal there, so we're going 5 cos theta is our initial velocity. So the final velocity will be the same, the acceleration will be 0 at time t, because we don't know what it is. I'm going to now write out my Suvats for my vertical position. So I've got vertically, I reach y, and my initial velocity is going to be opposite the angle, so we've got 5 sine theta. Okay, we don't know what v is. We know that acceleration is due to gravity is going to be minus 9.8, except we're going to look at the question in a second, and we put time t. So I was dealing with the information up to here, and I'm going to read the rest of it. The ball is modelled as a particle, and the acceleration due to gravity is taken to be 10. So I'm going to scribble that bit out and change it to the minus 10. Okay. We have to show that the equation of the trajectory of P is given as this. So somehow we've got to come up with that. Drawn a picture, written my Suvats, checked I've written the right thing, and now I use my equation. So looking horizontally, the only equation we have is S equals ut. Okay, displacement is velocity times time. We put in our information. So 5 cos theta, okay, times my time. So if I look at where I'm aiming, this equation does not have time in it. Okay, so it may be useful to get time in terms of x. So that's what we'll do. So time is going to be x over 5 cos theta. Right, now we look at the vertical direction. So vertically, we are using the equation that doesn't have v in it. So we've got s equals ut plus a half at squared. So that's from the front of your exam paper. You've got your equations. Let's put our things in. So we've got y is equal to u is 5 sine theta times by t. So I can use this t here. I'm going to write my t first of all because it's a show that equation. I don't want to do too many bits in one go. Plus a half times our acceleration is minus 10 times t squared. Okay, so let's put in, we're going to substitute in. I'm going to start writing up here so you quickly can see. So we're going to substitute t is equal to x over 5 cos theta into y is 5 sine theta t minus 5t squared. So we've got 5 sine theta times x over 5 cos theta. You can see things are going to cancel, which is nice. 5 times x over 5 cos theta, all in brackets, squared. So I just made sure, because I'm putting in quite a complicated substitution, I put it in brackets, so I remember to square everything. Okay, so now we can see the 5 cancels with the 5, so we've got x times sine theta over cos theta. Okay, now we've got 5 times, this becomes x squared over 25 cos squared theta. So we can see we'll be able to cancel the 5 with the 25. Right, Looking at the first bit, this should be a lovely familiar friend, and look where we're aiming for. We want x tan theta. Okay. If we multiply this bit out, we end up with x squared over 5 times 1 over cos squared theta. Now we know that 1 over cos theta is going to be sec theta. Okay, so this is x squared over 5 times sec squared theta. Okay, and then we can replace sec squared with tan squared plus 1, or 1 plus tan squared theta, which is what we're aiming for. So we've now got our equation as asked for. So just to briefly recap, every time we sketch a picture, we write out suvat, we use s equals ut horizontally, and then rearrange it to get t in terms of x, and we then use s equals ut plus a half at squared, substitute the t in, and then mess around with the trigonometry.